Okay, so today we're going to practice drawing magnetic fields, and I'm going to go pretty quick. So if you get kind of caught on this, just pause it so you can catch up to what I'm doing. When I do these drawings, what I always try to add is 3 sets of lines. And the first one is just a bar magnet. And so the magnetic field lines, they're kind of going to loop around like this. And we're most interested in the lines that are on the outside of the magnetic field and on the inside. And the one thing that you have to do is you have to draw arrows to show the direction that a compass needle points. And for this drawing, they're going to exit the north and then enter the south. And that's always the case with magnetic field lines. They always enter the south and they always exit the north. And the second one, you have 2 norths, so the magnetic field lines are going to interact with each other, but they're not going to cross. So they're going to push out on each other, and that's why they repel. So when I draw my field lines, I'm going to have them so that they're not crossing each other. And then the arrows have to exit the north, so they're going to look like this. Now, if we had 2 souths, the only thing that would be different would be there would be a change in the arrows. So if you had 2 souths, they would both be repelling as well, but the arrows would switch direction. On the next one, you have a north and a south, so they're going to attract. So the arrows are going to go from the north to the south, and I'll draw a couple lines. And then it's also going to kind of loop out like this. You'd have some lines that would kind of exit the north like that and then go back towards the south of that magnet. And then notice I'm drawing the arrows from the north to the south as well. And they're entering the south and exiting the north. Now, so that's for permanent magnets, for bar magnets. The next one is for an electromagnet, and you have to use the left-hand rule for a coil of wire. So my fingers are going to represent the current, and they're the positive current, and then my thumb is going to point to the direction of the north. And so in this picture, the electrons are going to the left, but the positive current is going to the right. So we're going to use positive current, and so it's looping behind it and coming down in front. So if I use my pencil to represent the core of the electromagnet, the current, the positive current, is going to come around like that. And so my thumb is going to point to the direction of the north. My fingers are going to show the direction of the positive current. And how did I figure out positive current is going like this? Well, it's because this is the positive side of the battery and it goes behind it first. So this will be the north, this will be the south. Not quite done yet because I have to draw some magnetic field lines. And you notice that the field lines I draw for this are going to look just like the bar magnet's magnetic field. I'm not quite done yet because I have to show the direction of the compass needle would point. So it's going to exit the north and then enter the south. I'm going to do them a little bit of overkill just to point out that the lines have to go into the south and out of the north. Now, one thing that is really important, we're doing 3-dimensional drawings on a 2-dimensional surface. So if you have an arrow that's coming out towards you, it's going to look like a dot. So it'd be kind of like my pencil coming right towards the camera. If the pencil was going away from you, then it would look like an X. If you think of the feathers on the end of the arrow, that would mean that it's going into the paper. So in this number 5, if the current's coming out of the paper, we're going to use left-hand rule, or right-hand rule number 1. And so your thumb is the current, so it's coming up. Wow. And then the fingers wrap around to show the direction that the compass would point. So I'm going to draw a set of circles like this, and because the current's coming out of the paper, that means the field would wrap around in a counterclockwise manner. So I'm going to put arrows like that, and remember now these arrows show how a compass points. So the compass would be pointing in different directions depending on where it is around the wire. Okay, now we have a single loop of wire coming out of the paper here, and then it's going into the paper here. So when I draw my loops, the only thing that's going to be different is that the loops are going to be having their arrows go in different directions on the top and on the bottom. And they're going to kind of be distorted because the fields can't really overlap because the lines can't cross. And so you'll notice when I draw this now, I'm going to use my right hand rule, current's coming up, so thumb's coming up towards the camera. My fingers are rotating around it counterclockwise. So in this part, they're going to loop like that. And I'll put an arrow on each one, a couple. And then in the bottom one, that's going away, so my thumb points down, so my fingers are wrapping around it clockwise. And so you notice that now when you loop a wire with a current, you get kind of the effect of a magnetic field for a bar magnet. So this end would be the lines are exiting, the arrows are going out, so this would be the north here. And then the south, where the lines are going in, just like we did up here, and like we did right here, they're going in. So that would be the south. All right, I'm going to move on to number 7. And in this one, the wire is underneath the compass, so we're looking at the magnetic field above the wire. So I'm going to use my pencil to represent the wire. The current's going up, so my thumb, I have to use right hand rule number 1. My thumb is going to be the current, and then my fingers point in the direction of the compass needle. So on top of the wire, they'd be going to the right. So my compass is going to go like that. In the next one, the compass is underneath the wire. So here's my wire. My thumb is the current, and my hand is underneath it. So that means the compass is going to point down. So on this one, the compass direction would be down like that. If you want to put a north there and a south, you can. And then on this one, you could do a north and a south. And that side one, I'm going to pause it and flip it over, and then we'll continue with side 2. Okay, so we're on the back side of the first practice worksheet now. And you notice that we have a current going to the right. So what's going to happen is the magnetic field lines are going to come out of the paper and then go into the paper. So I'm going to use my pencil to represent the current, and on my thumb is the direction of the current, and so on the top of the wire above it, my fingers are going up, so we'd have to represent that with dots. So on top of this, we're going to have dots that represent the magnetic field. So that means that they're coming out. And then on the bottom, if you think of it this way, they're on the bottom, they're going away from us. My fingers are pointing away. So to signify that, we have to use X's. So kind of hard to understand this one, but the field is coming out of the paper above the wire and then going into the paper below the wire. All right, next one. You have a wire that's going above the compass because you can see the wire all the way across. So what we need to do is we need to draw the field in. So with the compass below the wire, we're going to use our right hand rule again. Our thumb is pointing in the direction of the current, and I have my hand below my pen. That means my fingers are pointing up. So the compass is going to point like that, and this will be the north of the compass and the south. Okay, now the next one is for a coil of wire, and notice again that we have to look at how the positive current goes because we're using the right hand rule. So the positive current is going to go behind the core first and then come down in front. So my pencil now is the core, and I'm going behind with my fingers, which means in front they're going to point down. So the north will be to the right. So the north will be here, the south will be here. The current is going down like that. And then I have to still draw in some magnetic field lines to show how the compass needle points. And I'll do 3 sets like I always do. And have to put the direction that the needle would point of the compass, and that's what I'm doing that right now, and they point into the south and out of the north. Okay, now third right hand rule is your finger is going to represent, and different physics books do it different ways, but we're going to do it this way. Your finger is the index finger, and the symbol for current is I. So we're going to use I to stand for the current. Your middle finger is going to be the direction of the compass needle pointing, and then your thumb is going to be the push that actually moves the current. So you notice they're all at right angles. And so in the first one, the current's into the paper, and then the magnetic field is pointing up, and so my thumb will point to the right. So the force is going to move the current that direction. So that's going to be the force on that. The hard part about doing this rule is orienting your hand the correct way. That's the toughest part. Okay, 2 more to do on this. On the bottom, number 5, how would the external magnetic field behave here, or how would it point? So again, your finger is the current, index finger is the current, so it's to the right. The force is up, so my thumb is pointing up, and so you notice that my middle finger is the field, so that's going to point away from us. So we have to draw a set of circles, and I'm drawing a bunch because this isn't the field that's around the wire. There is actually a magnetic field around the wire too, but we're not going to draw that. This is the field that the wire is in, and that's going away from us, so I'm using X's. If you want, you could draw a field around the current too, but we're not going to do that. So that's it.